From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 542. In this episode, Scott talks with Dr. Felienne about exploring code smells in code written by children.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Felienne. Felienne has a PhD and is an assistant professor at Delft's University of Technology, and she researches the application of software engineering methods on a number of different things. What are you working on right now?
So my most recent paper that we're going to present in September is about software engineering methods for young kids.
How young?
Well, any age. What we did is we looked at the programming language Scratch. Do you know Scratch?
Right, absolutely. Scratch is like the canonical example for young kids.
Yeah, it's a visual programming language. It's made by MIT, and it's a standalone app, but it's also in the browser, so it's very easy for kids to play with. And they have a public repository of 14 million programs. And like on GitHub, kids can take each other's programs and remix them, which is like forking. So that also means that quality is important, because if kids go online, look at programs, games of other kids they like, they can look at the internals, at the source code, and make changes and make their own version of programs. So you can imagine that if it's full of code smells, then that's not so easy for kids to work with.
But if you've got, like when you said 14 million, I kind of was surprised. I thought you might say 14,000 or 140,000. I didn't expect 14 million. So then my first impression would be that, wouldn't that make the long tail really long? Wouldn't the vast majority of them just be garbage hello worlds?
Yeah, that's true. So we didn't inspect all 14 million of them. We took a sample of 250,000 programs. But you're right. For example, about half of the programs doesn't even have programming logic. So it's just pictures and images or sounds that kids like to play with. Because apart from being a programming platform, Scratch is also very creative. It's like crayons or pencils, but on a computer. So kids just use it to make pictures or drawings. But then the other half, which is not even really a long tail, that's a substantial portion of the programs, is serious and uses serious programming concepts.
Okay. So do you do some kind of cyclomatic complexity analysis and figure out that this is sophisticated and this is not, and then throw out the junky ones?
Yeah, exactly. We in fact did measure cyclomatic complexity for programs. And for example, we found that out of the 250,000 programs, 20,000 programs use procedures. So they create methods within their Scratch program. And of the programs with methods, over half of them, 56% of the procedures, has a cyclomatic complexity bigger than 2. So they have at least one decision point.
Oh, wow. Okay. So these are kids that are like 10 or 11, or how old are we talking?
Yeah. Sadly enough, we don't know the ages of the kids that made the program. So some of them may be created by teachers or parents that are enthusiastic to help their kids program, or maybe they just like Scratch themselves, because I must admit I have made some Scratch programs that weren't necessarily related to my research. I will admit that I have created a Flappy Bird clone just for my own enjoyment. So we don't, for this specific study, we don't have the ages, but because we have so many of those programs, it's very likely that lots of them are made by kids.
Okay, so you wouldn't know if some 50-year-old Scratch expert snuck in, but presumably they would be a little bit rare of a thing.
Yeah, so in a follow-up study that we're running now, we did an online, we created an online Scratch course. So a few videos and lessons for kids to learn Scratch with, and we made them available on the EDX platform. So that's a platform for online learning. And for those kids, we did ask them specifically what their age is, what they think of programming, whether they like it or not. And for their programs, it won't be as many, but then we will have in our next study a little bit more information about what their background is, what their gender is. For example, also whether their siblings are programming, whether they're doing it under supervision of parents or by themselves. So stay tuned for my next study.
Okay, so let me see if I understand this and kind of paraphrase it back to you. You've got this corpus of anonymous Scratch programs. You don't know anything about the authors. You're effectively Google in that you're a spider sucking in all of these programs, and you have no additional metadata about the programs, gender, age, anything. And you can make judgments only on the code based on looking at them. But then you have your secondary, coming soon, corpus where you'll have a survey alongside it, and you'll have all sorts of information. Would you then be able to correlate the two?
Yeah, so that's our plan. We are interested in seeing how much alike our kids in our online program are to the general public that we find in Scratch. And this is specifically interesting because in the study that we're doing in the online course, we are specifically teaching kids about code smells and duplication. So we're explaining them from the beginning of the course, this is an if statement and this is a loop. And also don't combine all your blocks together in very long groups because that will be harder to read. In another study we did, so that's not the study where we scraped the Scratch programs, but this is a study we performed at a high school in the Netherlands. We did a controlled experiment. We had 4 high school classes and we randomly gave them either a smelly version of a Scratch program or a perfect version. And we measured how they performed differently if we gave them a smelly version. And then we had long method smell and also duplication smell. So versions with lots of code clones. And we were able to measure that indeed kids perform way worse on programs with long method smell. It's way harder for them to read. So this was, of course, what we would have expected because these results have been found in the context of professional developers as well. So we know for a fact that combining all your Scratch blocks is bad because it will be harder for other kids to read. So from the start, in our online material, we educate kids about good software engineering methods. And then our hope is that they will produce less smelly programs than the general sample.
Interesting. Let's just take one quick second and redefine or define more clearly code smell, because first, I think there are a lot of people who use this term all the time, but there may be people who maybe don't have English as their first language who have not heard that term code smell too much. It's almost like a sixth sense, isn't it, that you have to develop? Yeah.
It's often a term that leads to giggles among people that aren't used to the term. So a code smell is a part of a program. It doesn't necessarily have to be an error. It can function totally correct. However, it's not structured optimal for, let's say, human consumption. It's not as easy to read or to maintain, to change as could be possible. And sort of the canonical example is a very long method. We've all seen 100 or 200 or 1,000 line methods. And maybe it has a very generic name like setup or execute or run. So there's nothing really there to help you understand it. There is an abstraction because it's a method, but it's so big that it sort of loses its value. Mm-hmm. And that is a code smell. And another famous example is called code clones, or sometimes called duplication. If you're doing the same or something very similar in many different places of the program, then suppose you have to change it in one place, you shouldn't forget to also change it somewhere else. So that's not so much an understandability issue or a readability issue, but that's really a maintenance issue, because if you're going to change it, you will likely forget some of the versions of the clones, and then you have a half-working program.
Okay. So there are, patterns in software engineering that we want to use. They're like ideal patterns. And then there's kind of anti-patterns. I guess code smells are kind of anti-patterns.
Yeah, definitely. Usually anti-patterns is used, patterns in general, I think, is used on a bit more higher level. Is more when we're talking about architecture. But in general, they're the same thing. There are things we like, which are patterns, design patterns, and there are things that are violations of a design pattern, and you can call them anti-patterns or smells.
Mm-hmm. And Martin Fowler says that the term was coined by Kent Beck when they were working on the book called Refactoring. And the thing that he says I think is really interesting is that it's quick to spot. Like the definition of a smell is that it's not something that you hunt for. You develop a sense, don't you, that something is wrong. Are you hoping that the kids will have an inherent code sense, a smelling sense?
Yeah, definitely. That would be so nice, because one of my secret motivations for this project, and it's not all that secret because I'm telling you over the internet now, is those kids that are playing with Scratch now, in 10 years, they will be in my classroom. They will be 18-year-old CS undergrads. And some of our CS freshmen have an experience of 10 to 15 years programming behind them nowadays. So then I tell them in one of the first lessons, hey, hello, you should test your code. And they're like, test? Why? I've never tested code. Hey, you shouldn't call all your variables var123, and you shouldn't call all your puppets in your game sprite123. But this is what they're used to, because lots of programming education aimed at kids nowadays is very much that. It's programming education. But software engineering, we know that it's not just you making a game you see with Scratch, with the fact that kids can remix their programs. It's very much a social endeavor, and maybe they want to come back to their Scratch program in 3 years, or maybe someone else wants to reuse it tomorrow. So if we don't teach them about TDD and refactoring from the start, we will be too late if they've already been exposed to so many programming environments and ideas, but not to the underlying, or let's say, encompassing software engineering methods that are also part of creating great software.
Mm-hmm. I think that the part that stood out, though, that you just said there, was that they might come back in 3 years. And I thought to myself, well, that's an eternity when you're 12.
Yeah, exactly. Yeah. So we were thinking about lots of exercises that we can do. So our online course was quite successful. So we're definitely going to do a rerun in the next academic year. So we're thinking of exercises where we're just going to have kids swap source code, for example. So here's a project you get from someone else in this course, and they've done maybe the same exercise or maybe a slightly different exercise, and now you change it, or you read it, you document it. And we hope that if we put them in the shoes of maintainers, rather than just in the shoes of a single programmer making stuff for themselves, that they will also experience how to make a project that's easy to maintain.
Right. And I think another way to phrase it is that you're teaching them a kind of empathy. When you say put them in the shoes of, you're saying be empathetic to future you and to your other people who might come upon your program and want to remix it.
Yeah. And lots of introductory programming material is very goal driven. And of course, that's cool. I mean, it's cool. You have a puzzle and you found the shortest path through the maze. You're done. You get a point or a coin and you move on to the next exercise. It's very encouraging and engaging to get stuff done. But often the angle of looking back at your code, and this is what Martin Fowler describes in his refactoring book as well. Everything is done, but now you're going to look at your source code another time and see what is better. That's like the test refactoring cycle that they talk about. The test pass, and you go back to your code. How can we make this more pretty? And in my experience, and we've sampled lots and lots of programming education material, that refactoring, that's not something that we teach kids. And that is definitely, I think we all agree that is a skill we want professional programmers to have. And we spend lots of time in university, but also outside in companies, coding dojos and stuff like that, trying to teach that empathy to developers. But and the earlier we get to them, the better, the more that they understand that's a part of programming too, the better they can decide whether that's a career for them.
That's so difficult, though, because you're also describing the larger human characteristic of delayed gratification. Do this thing and it will be better at some unknown point in the future. And, we can't do that when we need to eat good food and then, not die 30 years later. To tell that to a kid is difficult. I think your point about well, I solved the problem, right? It's almost like I was doing some long division with my 8-year-old yesterday, and he looked at a problem and he knew the answer. And my wife said, well, show your work. And he said, well, I don't want to show my work. I got the right answer.
Yeah.
Like, it's done. And that's basically, well, it compiled and it ran. Why are we still talking about this?
Yeah, I mean, getting people, and including kids, which are also people, to have good habits and to naturally want to make things pretty, even though there's not a reward immediately. That's difficult. But we do think that tool support could help there, because the IDE, let's say the Scratch IDE, it's not really an IDE because it has features that are mainly aimed at writing code. The way that Scratch is made, it doesn't have smell detection. It doesn't have a refactoring angle. And if you see my papers, the research I've done over the past year, and if you're also familiar with my work on Excel, it's kind of clear where I'm going, because an obvious next step is to make an IDE, a smell detection engine for Scratch. So we've used that in analyzing our 250,000 programs, but we want to make that user-facing. So imagine an alternative Scratch environment where there would be a counter for your code smells. And that's the thing that will give you points if you lower the code smells. Then you can make it more visible to kids whether they're on the right track or not.
So if you built in the detection of this into a tool like, things like ReSharper and Visual Studio do with C# and F#, where they put a little light bulb over code that they think is weird, or if you think about Word and Excel, where they, Word will put a red squiggly for spelling errors and a green squiggly for grammatical errors. You could do that for Scratch, but doesn't that then become a crutch? I mean, there are people who say that, you shouldn't be using spell checkers in Word when you're starting to write, because it is a crutch and it allows you to, not learn how to spell.
Yeah, absolutely. So in the beginning of the podcast, we talked a bit about having that sense, that spider sense that tells you immediately this is too long. But that's not something professional developers were born with either. That's something you get by training. And after a while, you don't need the IDE anymore maybe to tell you that method is too long. You know it. But how do you develop that sense? So we definitely think that tool support could help there, teach kids about, maybe this is a little bit too long, but also do it in a challenging way. You don't want to say something like, that's bad. Maybe you want to a kid made a program and they're at that point where they're maybe thinking about what's my next move. And of course you could detect that by looking at mouse and keyboard movements. Then you could maybe show a pop-up or an extra challenge. Here's a quiz. We've observed by doing some small code analysis that you could also split this group of blocks in two. Do you see how to do it? So then, it's not annoying. It's a crutch. It's more an encouragement to think about it. So we definitely don't think that on every Scratch game you make, you want to have, 0 code smells and everything should be perfect. But we do think we can encourage that reflection on source code quality a little bit more.
There are something like 80 or 89 different code smells that have been identified. But again, long tail is long. What are the code smells that you watched for specifically? What are the top 2 or 3 code smells that show up?
Yeah, so there are a few interesting code smells that are Scratch specific that we looked at. So Scratch is an event-driven language where you can have the environment react on events, and an event can be a mouse click, for example, or a key press. But users can also generate their own events. For example, if I'm the main character in my game and I bump a wall, I can broadcast a signal, I'm bumping against this wall. And other sprites can react to that by, for example, deducting a point or playing a sound. So a Scratch-specific smell is where you create an event, but there's no event handler. No one is consuming that signal. So we looked at those sort of specific Scratch code smells. And other than that, we sort of try to limit ourselves towards existing simple code smells. So long methods, clone detection, and a little bit of naming as well. Because of course, there are some trade-offs in code smells. Because if you chop a method up into lots of different pieces, then they will have to communicate with each other. And then increasing the one smell is decreasing the other smell. So for that reason, we thought we were just going to look at some simple code smells where we can have actionable advice to provide to kids. Because something like, I don't know, feature envy, where one method is connected to fields of a different class, those things are way too complex to reason about, not just for us, because we could do it as programmers, but to communicate to a kid what is happening and why and what is a solution isn't all that obvious.
Are you going to apply these learnings to other languages? Is there something about Scratch that makes it like the perfect programming language as an example? Is it the corpus of information that you're pulling from? Are there no other languages that you could, spider?
So the reason that we look at Scratch is indeed because it has that huge public repository, and also because it's obviously made by researchers that have thought about that, because they have a clear license agreement that allows people to inspect the programs if they're shared. So if you're a kid and you share your program, you agree with the whole world being able to see and analyze and process your program. So they've really thought that through, and that's also what enables us to do this research. We couldn't have done that on another language because they don't have the data. So, for example, a language like Blockly, that's the language behind code.org, which also very nice, very similar, also a block-based language, so it's very similar to Scratch. They have not allowed, with an API or something, researchers to crawl all their programs. So it's the most popular language as far as we know that makes it easy enough for us to process. But there would be nothing against doing something else. Suppose there would be a website that collected Python programs written by kids and also listed kids' age and gender and socioeconomic background of their parents, and I would be very interested in analyzing that too.
Interesting. Yeah, if you could call code.org and people like that, and you could, like you said, you could search for it, but even more, if they could take the sum total of all of their information and make it available as a data set or dump of some kind.
Yeah, we would be very happy if they would do that, because for Scratch, I'm sure you can provide some links with the podcast. So our scraping program, and that includes parsing of the JSON format of Scratch, we've put that online on GitHub. So if other people want to scrape the Scratch repository as well and process them for whatever other spells they want, we've made that available for other people to use. So we really want to encourage this type of research, because again, you didn't expect 14 million programs, and I don't know how many are written every day, but the thousands and thousands of Scratch programs are still contributed every day. So there's so much to learn from about how kids program, and you can also, of course, track these programs. And we don't have ages, but we do have the username of the program. So you could even zoom in on one user and see how their programs evolve. And you can also investigate what in Scratch is called a remix tree, how the forking history of a project, how people are changing it, what they're changing, what they're adding, what they're removing. So a potential angle we haven't followed yet, but we could follow, is to see what kind of refactoring kits apply themselves. So you take snapshots of the program and you see what changes they make. Maybe there are already improvements that they are making for reasons we don't know. Maybe they are renaming their scripts from Sprite 1 to Puppet number 5, or a cat, the green cat with the red hat, or something like that. So that could be an additional source of refactoring, because you can only learn so much by applying grown-up software engineering to Scratch. There might be code smells or refactoring patterns that are unique to kids or unique to Scratch that we cannot invent by looking at what responsible adult professional developers do, because they're in a totally different context.
Yeah, that seems like adding the additional dimension of time, and thinking about Scratch and how it moves around their site, as if you think about it in terms of Git and GitHub and forking and cloning, would definitely add a whole new way of looking at this. You've seen those D3JS kind of graph, kinetic graphs where someone points a system at GitHub, and you get this kind of family tree over time to see an application grow and change. You could see how the child's understanding of code grows and changes over time.
Yeah, exactly. And see what blocks they use. So in our paper, we have an analysis of all the blocks that are used, and because the blocks are divided in 10 different categories for sound and movement and things like that. So you could also see how the toolbox of a kid is maybe growing, but maybe also shrinking. Maybe they develop their own favorite habits and don't use a certain category or type anymore after a while. That's all stuff we haven't explored yet, because this was the first study of this kind, and we just wanted to have a big overview of the whole data set. But those are things to zoom in to for us, but maybe also for other people.
So what can we as professional engineers who are listening, learn from this as far as it relates to our daily work? And I wonder how often we see people who have been coding as long as these kids have been alive. And have we forgotten our sense of smell? Do we just give up and write smelly code and move on because it's just so tiring?
Yeah, that's a very interesting question. What can professional developers learn? So I think one of the things is project abandonment is way greater in these Scratch programs. So if kids are done with a game, they just drop it and rebuild something else. They're not going to mess with something clearly bad or broken or super smelly. Whereas in a professional context, of course, you cannot just say, I don't like this code base anymore. I'm starting anew with something else. So not all the lessons, I think, are translatable to a professional context.
Mm-hmm. I found it a little bit frustrating working with professional engineers when you start applying static analysis algorithms to their code, because I've always felt like the professional engineer could just say, well, says you, like as a retort. So I might say, well, I've taken a static analysis and this code is kind of smelly and here are the smells and it has a cyclomatic complexity of X and that's bad. And they can just say, well, says you, I don't want your feedback. I don't want your feedback. Do the kids take this feedback and they change the way that they think about code right away? Or do they say, well, it works, so it doesn't matter if it's smelly?
Yeah, so we don't know yet. That's one of the things we want to figure out in that follow-up study where we educate kids about smells from the start. From lesson 1, we talk about code quality. So we hope that will help. And also what helps, I think, both in professional context, but also with kids, is to make it very tangible and concrete. So if you have results, not the static analysis tool says that, but hey, if you call your variable cat instead of sprite1, it will take another kid 10 minutes less to read your code or something like that. So there are studies, and more studies like that in software engineering are being done, studies with human subjects where we really want to measure what is the impact of a code smell. How bad is it really? Because with lots of these smells, you can spend the whole afternoon getting rid of all your smells, but what if you want for you, for your customer, for your developers, team, the people that also have to work on the source code? So I think making it very quantifiable is a way to make it easier for people to understand why they need to do the investment, both kids and professional developers.
Do kids write smelly code by default? Like unchecked, do they do just long methods, or do kids discover functions on their own?
Yeah, so for this data set, we don't know what they found on their own. The interface of Scratch, of course, is very encouraging to just try stuff. This is contrary to code.org with Blockly, because that's not a free playing environment. You get 4 blocks and then you do a puzzle. And if you perform the puzzle correctly, then you get another block is unlocked. So there really the features are presented to kids step by step. Whereas in Scratch, you can just, it's called make a new block or something like that. I didn't know in English because my Scratch is usually in Dutch nowadays. But it's something like create your own block. So you can click it and you can see what happens. And did this? Now I'm getting my own block that I can use. So I don't know if much of it is self-explored or from a book or from a parent or a teacher. That's hard to measure by just looking at the programs.
That would be really interesting to understand, but I'm definitely looking forward to your follow-up, because I think that a lot of us who are listening to the show have thought about doing volunteer work or teaching kids, whether it be our own kids or the kids that are in our lives, code in various ways, sometimes Scratch, sometimes more advanced languages like Java and C#. But I know that I haven't thought about including the concept of smell right off the bat.
Yeah. So I said we looked at lots of programming material, great books that are really good at explaining programming essentials. Do not talk about that software engineering angle. So don't beat yourself up about not thinking about that, because apparently, teaching programming, maybe software engineering has done a bad job of marketing itself in a sense, because apparently there's still a very clear distinction between learning to program and learning to be a software engineer, where I am a software engineering researcher, so I might be slightly biased, but I would say it's not a difference. Programming includes thinking about the quality of your programming. Testing is programming. It's not testing and programming. It's the same thing. But somehow when we think about teaching people programming, we're really focused on making them able to get stuff done and not teaching them to reflect on quality.
I really like that. That was like the quote of the show. Like, testing is engineering. It is part of software. It shouldn't be treated as a separate thing.
Yeah, it's true.
Very cool.
So the earlier we start, the better.
Absolutely. So people can find you at Felienne.com.
Yes.
Felienne, and I'll include links to your blogs, your publications, and they can all find that, including public speaking, where you've spoken and where you're going to be speaking, all on top of your blog. Your blog goes back with public speaking going back many, many years. You're out there in the world talking about this stuff all the time.
Yeah. So I spent most of my research career doing the same thing, the same advocating work for Excel that I'm doing for Scratch now. Excel is a programming language, and we should think about quality in spreadsheets. And I'm pivoting a little bit now towards programming education, but the core of my work, software engineering for the masses, goes back to when I started my PhD degree in 2008.
That's fantastic. Well, thanks so much for sharing with me today.
Thanks. It was nice to be on the show.
This has been another episode of Hansel Minutes, and we'll see you again next week.